Okay, welcome back. So this is where we left off. Let's run main here just quickly. You could see that we don't have any linking issues. So recap quickly. So we have data node class completed here. Okay, we have the binary tree class that we need to complete, and we will be testing our code right here. So first thing we're going to do with a binary tree is to create an attribute for the root. And root itself is an actual node. What kind of node? Well, data node class from type data node class. So let's go ahead and do that. So private data node root. Now, as is, right now, root is null. Okay. So maybe what we would like to have here is a constructor for this class and enforce that rule. Make sure that root is null the first time you create a binary tree. So let's go ahead and try that. So for that, so public, so let's go ahead and do our constructor here. And that would be binary tree. Okay. So this would be our constructor, and it will simply, notice I'm not putting any arguments here, it will make root equal null. So we can go ahead and create an object of type binary tree now. So let's go ahead and do it right here. And we could do something like this, binary tree. Let's call it BR1. Equals new binary tree, semicolon. Okay, so I'm just going to run this just to make sure we don't have any issues. And everything is good because it's running that constructor and it's ensuring that root is actually null. Okay, so now we need to start worrying about how do we insert a node starting with root, if it's the first one, or if a node that's given to us is the first one. If not, then where do we insert it? Either on the right or on the left. Okay, I'm going to do this in two parts. I'm going to have an insert method. However, I'm going to override it because I'm going to call the overrided version of the initial one. Let's do the initial one. So public, something like this, void, and let's do an insert method, and you will simply pass to it int key and string data. Okay, so when we do this, we will have to ask a question first. Is root null? If it is, go ahead and create or make root equal this or put this payload in the root, right? So that means we're starting at the beginning. So if root is equal to null, now we know initially that would be true, right? Then we will go ahead and do root equals, we're going to create a new object, right, of data node with the key and the data in it. Semicolon. Now, what if root is not null? What does that mean? That means we already had, so we came back and we already had an item in root. So now we need to go either to the left, create a child, or a leaf, either to the left or to the right. Well, this is where I mentioned that I'm going to override this method here. So it's basically under the else, I'm going to call this function here. It's an insert function, but it's overridden, right? And it will, actually it's overloaded since it has different parameters. And so we're going to overload the insert method, and we're calling it from within. It will take a key, just like this one. It will take, so let me just go ahead and do a key here. I'm not defining it here. So we're going to get a little red squiggly line because we don't have one that has this additional parameter, which will be an actual node. So in our case, we're going to have to pass root to it. So notice here, we're going to get a squiggly line here because we don't have this method defined. So let's go ahead and define it. So public, and this is really where we're going to be going ahead and determining which of the leaves we're going to create. Right child, left child, and this is where we're going to insert the logic based on the key value as to which direction we're going. And let's do an insert here. And we're going to have int key. So now string data. So we're going to match the signature of what's on line 14. Data node. And let's call it node. And notice now I no longer have squiggly lines. Right? So this will work. Except we're going to have to make it work now. So as you can see, the definition is empty. So this is all going to depend on the key value to decide if we're going to go left or right. Okay? So this will be a simple if statement here. So we're going to say, okay, all right, so how do we do this? We're going to do key is less than node.getKey. If that's true, we're going to do certain things. Else, if it's not, so let's go ahead and do an else here. We're going to do other things, which is go on the right. So this block here will be handling the left side, and this block here will be handling the right side. And we're going to use recursion with the same method, and because we may be going several levels deep to get to the last leaf insertion. So here, first, let's go ahead and make sure that did we reach a leaf? And if we have, then we know where to insert a new leaf. If not, we keep going. And how do we keep going? We're going to call the insert, the overloaded insert method again. Okay, so if node dot, and remember on the left side here, get left equals null. So we are looking forward as to what is it equal to. So if it is null, that is a leaf. So we need to insert here. So node dot set left, and then put the node in there. But how? New, we're going to create a new one. Data, what was it again? Data node, and the values that we have, key and data, right? And then a semicolon here. Now, what if it's not a leaf? Then else. This is where we are going to call the insert method right here with the actual key, the actual data, and the node.getLeft. And let's put a semicolon here. So this is the key components. Let me just move this one up a little bit for the insertion on the left. Else, we're going to be doing the same thing for the insertion on the right-hand side. So if, and again, node.getRight this time is null. Again, we're going to insert. So node.setRight is going to be equal to new data node insert the key and the actual payload as a string. And let's see here, did I miss somebody here? I'm getting a small error here. Let's see here what's going on. We are setting right, equals equals null. And I'll come back to it. Let's see what's going on. Else. And so what are we going to do here? And the way we're going to handle this is if it's an else, that means we're going to call the method insert from within, right? So again, insert, and this would be the key, the data, and node dot, and in our case, get right. Right, so let's go ahead and put a semicolon here. Now, well, this is great, but let's see what's going on here. Why is this thing giving us a squiggly line here? Let's see what the warning is saying. Get right cannot be applied to data node, so let's go back here. And we should be, it is set right. I'm sorry, I got the wrong method. Indeed, this is why you read what it's saying. It is set right, and now we're good. Right, so we're going to set to the right. Okay, always read your errors, okay? And now, all right, so we got this. Let's go ahead and test it out. And let's take our BR1 and let's go ahead and insert some data in there. And what kind of data? Well, you need a key, 50, and you need a payload like a car, for example. Well, let's do another one. BR1 dot insert. Let's go ahead and put a key here of 30 and comma, and we're going to have a truck as a payload, truck. Okay, so let's go ahead and do another insertion. And let's go ahead and do BR1 dot insert. And let's put 78, comma, and let's put a bus here. Right, so let's go ahead and run this. Now, obviously, we're not going to see any results out of this. We just want to make sure this is not going to crash. But what it's doing, it created a tree for us where 50 is the root, right? So the car will be in the root node. And then on the left-hand side, we would have the truck. On the right-hand side, we will have the bus. Now, we can keep on going with this. So let's go ahead and do this. BR1 dot insert. And let's put a 21 here. So we know we're going to be heading to the left here. And let's put bike. Okay. So what this will do is it will first, so we'll compare to 50. Obviously, we're going to go on the left. We're going to compare to 30. We're going to go on the left. And this will be the last leaf on the left-hand side. This here will be the last leaf on the right-hand side. Okay? All right, so the trick now is to traverse this and be able to display the content of the binary tree. Okay, so those are some of the items or tasks we'll be tackling in our next video. I'll see you then.